Hi everyone, welcome to today's Leetcode challenge. So today we'll be doing the problem container with most water. So you're given an integer array height of length n, and there are n vertical lines drawn such that the two endpoints of the ith line are I, 0 and I, height of I. Find the two lines that are together with the x-axis from a container such that the container contains the most water, and then return the maximum amount of water a container can store. Notice you may not slant the container. Okay, great. So in this problem, we are given the input, which is height, which is an array of integers that represents the height at every specific index, and the output is going to be the area, the maximum area that the water can contain. As you can see in this example, the point where the left height is higher than the right height is when you can actually contain the water, and for every one of those instances where the left height is higher than the right height, you would calculate the area and then find the maximum area. So let's get started. So as always, I'd like to start with identifying what the input is. So in this case, our input is going to be an array of integers, and our output is also going to be an integer. So here, our array of integers, let's take this example that was provided to us, which is 186254837, and for that specific input, our output is going to be 49. Now, the next step, let's look at what the constraints are to this problem. So the provided constraints are the height.length, which is the last, actually it's the length of the array. Height array is going to be equal to n, which is the number of vertical lines, and each of those vertical lines can range from 2 to 10 to the 5, and our height, each of those height value is going to be either 0, which is actually no vertical lines, or 10 to the 4 for each of those vertical lines. So those are our constraints. Now let's focus on what the time complexity and space complexity of the problem that we would want to solve this to. Like, this is what we're actually trying to aim to solve. And so we're trying to aim to solve in O of n time, and for the space, we're trying auxiliary space complexity, we're trying to do in O of 1. Basically, we're trying to do this without adding any space. And so let me explain the diagramming and logic of this problem. So we will try to solve this using a two-pointer approach. And how do we do this? So let's take the given input, which is 1862, this array, and the very first thing that we have to do is have two pointers, obviously. And so each of those pointers, the very first pointer is going to be starting at 0, and then our right pointer is going to be the height dot length minus 1. And so that means visually it's going to look like this. So basically our left pointer is here and our right pointer is here. So those are the two things that we have to initialize at the very beginning, and then we also have to initialize our maximum area, which is going to be initially 0. So how do we calculate the area? So whenever the left pointer is greater than the right pointer, then we basically calculate the area and then move the left pointer to one direction into the right side, while keeping the right pointer as is. However, if the height at which the left pointer is greater than the height at which the right pointer is, then we move the right pointer to the left side by 1. So basically, we're moving the left pointer and the right pointer in an inwards direction, which is basically you're moving the right pointer in this direction, and you're moving the left pointer in this direction. That's how we're trying to move these. And so while doing that, we're trying to also calculate the area along with it as well. So how do we calculate the area? So the area over here is going to be the right pointer minus the left pointer multiplied by the minimum of what? So right pointer minus left pointer is going to give you the length of the container. So basically, if the left pointer is here and the right pointer is here, then this length is what r minus l gives us, and then we have to calculate the minimum height between the right and the left, because that minimum height is the height up to which the water can be, and so that would be the area that we have to calculate. So basically, it's going to be the minimum of height of L comma height of R. So this will calculate our area, and then we just have to calculate the max area is going by calculating math.max of max area comma area. So that is basically our logic. And we move the left pointer and then the right pointer based off of which one is higher than the other. So remember, whenever the left pointer, whenever the height at the left pointer is greater than the height at the right pointer, that is the only time we can actually contain the water. And on all other instances, the water will just like flow out, because that's what actually keeps the water inside as a container. So if the height of the left pointer is greater than the height of the right pointer, in this case, we move the right pointer inward by 1. Otherwise, we move the left pointer inward by 1. So we're moving the right pointer to the left and then the left pointer to the right when the condition is where the height L is greater than R or the other on the opposite direction. So that's how this logic works. Let's see how this works in code. So very first, we can initialize our max area to be 0. And then our left pointer is also going to be 0. And our right pointer is going to be height dot length minus 1. Okay, so now we have all these things. We can have a control loop that goes as follows. While left pointer is less than right pointer, we're going to say let area is equal to r minus l times math dot minimum of height of L comma height of R, and then our max area is going to be equal to math dot max of max area comma area, and then if height of L is greater than height of R, then in that case we move the right pointer inward by 1. Otherwise, we're going to move the left pointer outward by 1. So eventually towards the end, we would be able to calculate the maximum area, and then that maximum area is what we would return. Let's see if this works. Okay. Great. What do you know? It works. So it's pretty efficient, and runtime wise and memory wise, it's pretty efficient. Thank you so much for watching, and I hope you have a great rest of your day.